Hello, my name is Taruna Labatu, and today I'll be showing you my Project 3, a pathfinding program that I've made in Unity. We've already entered Unity, and this is basically the entire pathfinding program right here. So, as you can see, I have three defaultly set maps. So one very large one, it's got over 1,000 cells. This guy's got around 200 cells. And this very small 5x7, which once we run it will produce numbers that will replace these heuristics that will be determined shortly. As you can see, there's a couple of there's a couple of variables that haven't been changed at all because we haven't ran anything. Path length is 0, steps taken is 0 for all three of them because, there's no path, and no steps were taken to make a path, so before we do anything, I just want to show you the potential options we have here in terms of algorithms. I've implemented a Manhattan path searching, Euclidean, and maximum. We're just going to start off with Manhattan, and these two buttons will determine how fast the pathfinding will happen, the path creation as well. So, I guess let's begin. I'm going to press start, and all three of these will begin simultaneously. As you can see, they're mapping out the path that was searched for. The 5x7 is already finished and is actually displaying all of the heuristics. The distance, basically the distance from the goal and the distance from the beginning node are displayed, and the big number in the middle is the combination of both, essentially the cost to get there. So basically it attempted to find the best path in terms of costs via the Manhattan algorithm. See here that I think map number 2 is just about finished. And there you go. It has finished and it has reached the goal, which is at the bottom right here. And this leftwise is going to take a while, so actually let's speed it up, shall we? Speeds up to 3 and 4, and we go really fast, and we've already completed it. Look at that. So there's a very windy path, and as you can see, we have a number of variables now showing up that weren't there before. Let's just take a look at this left grid over here. The 1,000 cell grid has a path length of 108, and it took 731 iterations of searches to find this best path according to the Manhattan algorithm. So that's pretty cool. You can see the rest of the variables here for the other two. Let's change it up. Let's try the Euclidean, and we're gonna press start again. Oh, really fast. I didn't change the speed. I'm gonna put it down to 3 for next time. But there you go. There's the Euclidean. You know what? One moment. I'm going to compare the number of steps taken. Actually, now I'm impatient, so let's speed it up again. So it took one more iteration of searches to actually finish the Manhattan search, as opposed to the Euclidean one, which took one less. How about the maximum for this 1,000 cell grid? Let's find out. Oh, it's about the same. That's interesting. Yeah, that's pretty cool. So yeah, these are the three algorithms. They're implemented in their own ways mathematically, and they attempt to find the best path, which is what we've done here. Let's see here. So yeah, final path is drawn. The heuristics are shown in the top right, guys, so you can look at that if you choose. But yeah, actually, that's pretty much it. Really nothing else to show about this. Yeah, this is my 3 default maps and the pathfinding associated with it. Created a couple of tiles. You can see the borders and the initial graphs before I started this were custom tiled, if only just one tile, but they were custom. And yeah, so that's my program. Thank you for watching.